So what we wanted to do with this session was to focus very much on what the capabilities within the systems design process or within the tool chain between MapleMBSE, Excel, MapleMBSE and Teamwork Cloud, and just focus on that. And we thought we'd put together a live demonstration, just showing the sequences in terms of the workflow. We're all working remotely from our own homes. We're using domestic connections to the system. We're working with an offline or an online Teamwork Cloud model. So there are many variables in terms of what the performance is going to be like on this. So please bear with us if there are any sort of glitches or delays in the process. But we will get through this. So let me just start by really breaking this down into what we're going to cover today. I'm just going to set the scene just in terms of what is the problem that we're trying to address here with MapleMBSE through Excel-based access to systems and models for all stakeholders, not just the systems engineer. And we'll also talk about what tools are available within the tool chain in order to manage information flow and access across many multidisciplinary stakeholders. I'll pass it over to Barani, who's going to set the scene on the demo. As I mentioned, this is going to be a three-way performance around the systems model, and then in the end we'll wrap up with a questions and answers session. So what's the problem we're trying to solve? Well, I think the main issue that we've been sort of observing among our customers is that typically, the people that we deal with are the design engineers who are using tools like Maple and MapleSim to perform their tasks, their design work, in order to make design decisions. And then and a lot of time that information is coming from a systems model that's been created by a systems engineering group or a systems engineer who is basically creating the architectural model as the sort of authoritative source of truth. So everything that defines what is required of the system in terms of its structure, behaviors, requirements, and then parameters are lodged in the systems model. And then the various stakeholders will take that information, do some work with it in their own tool chain, and then somehow communicate the results of their work back to the systems engineer, who can then has to translate that information to something that he can then put into the systems model using tools like Cameo or Rhapsody. And this is where we see the friction. This is a very human interaction. There's very often there are misinterpretations or miscommunications. Errors start creeping in. There's lots of unnecessary design reviews, lots of time wasting happening, and moreover, there's a sort of erosion into the confidence of the system every time something like this happens. So we see this as a very high friction stage in the process. So our proposal is, well, why not give the stakeholders direct access to the systems model? But don't force them to be using tools like Cameo or Rhapsody to do this, because this is not their primary job. So let's give them a tool that everybody's familiar with, and that's Microsoft Excel. So essentially, what we're offering through MapleMBSE is a way of being able to bring up a task-specific view within Excel that is relevant to the work that each stakeholder is working on, and then any additional information that's entered into those views can then be sent back into the systems model without anybody knowing anything about systems engineering, about what the structure of a systems model is, or even things like SysML and so forth. Everything can be done within the Excel environment. Now the systems model becomes the transport mechanism, or the communications mechanism between all the stakeholders and the systems engineer. Now all that information, it resides in the system model in a way that's consistent and understandable, and that becomes the basis for discussing those changes during the review. And once those changes are deemed acceptable, then they can be authorized by the systems engineer to be lodged into the main systems model. We'll talk more about this in the workflow we are about to demonstrate. But not only that, each stakeholder can collaborate with other stakeholders that aren't systems engineers through the systems model. So compliance testings, trade studies, and the example we're going to show today is a sort of very high level failure mode example, which involves design engineer communicating with a safety engineer, and of course with a systems engineer as well. So what MapleMBSE is, it's basically a tool that allows access to the systems model through an intuitive Excel user interface. You can view the information that is specific to the work that you're doing, enter new information, add more detailed information, modify parameters, and so forth. And all of this is done through a synchronized bidirectional connection. So it's critical to understand that MapleMBSE is not about file import and export. We're not generating XLS files, doing something with it, and then pushing it back in as an XLS. It's completely synchronized and integrated with the systems model. So any changes that are made in the systems model will be immediately reflected in the views within the MapleMBSE Excel user interface. Highly customizable, and necessarily the tasks are going to be very different for different people. It requires some effort to create those views, and we'll in future webinars we'll talk more and more about this. But the important thing here is it's highly configurable and very open. And then, of course, it's integrated with sort of the standard SE platforms. At present, we support SysML specifically for Rhapsody and Magic Draw through Teamwork Cloud, or Magic Draw and Cameo. And in the future, we are planning on a Capella release as well. Okay, so with that, I'll pass it over to Bharani, who will describe the demonstration that we're going to go through. Let me stop my sharing.
Thank you, Paul. Share my screen. So today's demonstration is about collaboration. We'll show the different features that MapleMBSE has to ensure that different users can work with the system model, opening their MapleMBSE interface through Excel and accessing the same information, editing it, and saving it back to the model. So for collaboration, what as a system engineer, they have control over the scope of the model. So they define the model elements or the part of the model that they need to expose it to certain users. So in today's workflow, we will see that Paul will do an import for master equipment list. So, and then Sergio will do a failure mode simultaneously. And then as a part 2 of the demo, you will see Sergio to perform failure modes on the components that has been imported by Paul. So as a scope, I could restrict the part of the model that's exposed to a user. So that's what we mean by scope here. And element locking and unlocking. So the locking feature works similarly on how you will be using it with Magic Draw or Cameo. So in MapleMBSE, once you start editing the model, you will acquire locks. When you save it back to the server, you are going to release the logs automatically. So the user doesn't need to worry about locking the element and unlocking it separately. And for branching and merging, the user has the ability to create a new branch to commit. So we will see a demo of how this is being done with MapleMBSE 2. And for the part with conflict detection resolution, this is a part that the user actually doesn't need to worry about. It's completely taken care by MapleMBSE on the back end. So it will ensure that there are no conflicts, or if a part of the model that two users are working simultaneously, one user deletes it. So all these are maintained, or all these are kind of controlled based on the logs and the conflict detection ability of MapleMBSE. So we did see these model scope definition, and I also explained you the element locking and unlocking. When a user starts editing a model element they see in MapleMBSE, it will automatically acquire locks, and the other user will now just see a message saying that they are not able to lock the model element because for the reason that it's being locked by a different user. And for the branching and merging part, so I'm just skipping through this because we are going to see this all on the demonstration. And so for the demonstration, so I'll be playing the role of the system engineer. So Paul is going to create a MapleMBSE import. So he is going to import master equipment list, and Sergio is going to perform a failure mode. As a first part, he's going to do it simultaneously along with Paul, and in the next part, he's going to perform failure modes on the new import of the MEL that Paul just added to the model. So for this, we are going to have I'm using a table that's publicly available from the Lunar Relay satellite report. So I'm just taking a table for the MEL import, and then we'll perform FMEA for a system function that's already defined in the model, and then we'll show the workflow of how the user can access the latest changes, that's the import components, and then use it to perform failure mode further on it. So the workflow that we are going to see for the failure mode is the one that's highlighted here. So we are going to have some system functions. We are going to identify failure modes for it, create SOD, which is the severity, occurrence, and detectance. And based on the SOD numbers, we are going to calculate the RPN, which is a risk priority number. And this is going to be saved into the system model as SysML elements. And now, based on the failure modes we identified, we are also going to add some requirements as a mitigating action or a test plans that will be saved back to the model, based on which the model has to be further updated. And this is kind of an iterative process till we decide the system is safe enough to move on to the next phase. So I'll stop my screen. I will get back to Paul. So he is going to start with launching MapleMBSE and starting import of the components.
Okay. So I'm guessing you can see my screen. Yeah. Can you see my screen?
Yeah.
Okay. Okay. So what I'm going to start off with is the master equipment list, which is essentially a laundry list of all the components that are going to go into the the satellite. And these are broken down into various subsystems or sub-assemblies, but the sub-assemblies are basically what you're seeing highlighted in gray here. Just make that one there we go. So these are the various sub-assemblies. But in an Excel spreadsheet, I as an engineer could see where the breakdown is, but in terms of the structure. But there is nothing intrinsic in the spreadsheet that creates those relationships between the sub-assemblies and the full assembly, which is the communications assembly. So there's some work that needs to be done in order to get this into the systems model. Now, typically what would happen is that you'd give this to the systems engineer, and the systems engineer would then have to break this down in discussion with the design engineer. But with MapleMBSE, we can actually do this ourselves. So what I'm going to show you is I've just fired up. Close that. Okay. So I've just fired up MapleMBSE, and it's now connected to the Teamwork Cloud server, and I need to now put my credentials in to log in, and then typically what you'd have is the whatever models are available to you, or what branches are available to you, and also you can get a sense of who else is working on the system model. I don't know, Parani, do you have any comments on this?
Yeah, so this is the revision browser. You get the most recent commits. You see the list of users who have previously committed or made changes to the model. And you'll be able to filter these lists based on the author who has committed, the date when these commits were made to the server.
Okay. So also you have the option to select a branch within the model. I'm just going to focus on the trunk here, and I'm just going to connect in. Okay, that was amazingly quick. Okay, so now I'm actually connected, and what we see here is a template that's been created that where we're going to expect to bring in the information from the MEL. So this is a previously defined template that is based on the layout of the structure of the MEL file. So now what I'm going to do is load in, or go into the add-in section, and I'm going to import my Excel file. Okay, so there's my file. Now there's a lot of crunching going on in the background here as it starts to build up the SysML records based on this information. So this takes a little while to go through, and I did mention there are some delays in this. There we go. All right, so now I'm informed that it's created the model, which has 31 records, and updating for 49 records. But anyway, the information is now in a structure that I can start doing some work on this. Now, at the moment, it's still a linear list. So I actually need to apply my knowledge to this list in order to create the hierarchical structure that we need to put into the systems model. And the way that we can do this is basically we provided an assembly tab here. At the moment, what we've just got just a linear list of all the components. There's no relationships being defined in here. So what I'm going to do is I'm going to start with the high level. So I'm going to go top down. So we'll start with this. This is actually a communications system, and I'm just going to paste that into here. Now we've created a new record. Now let's go back to. I now need to say, okay, well, what are the components of that system? Well, we can see here we've got 1, 2, 3, 4, 5. I thought it was 6. Anyway, I think it's 6. Yeah, there's 6 subsystems. I'm just going to do one. I'm going to step through one, and then we'll. I'll pass this over to. And I'll keep working on this, but let me copy this subsystem, and I'll just drop this into here. Now I've defined. I've said that this subsystem or this subassembly is part of this is a subsystem to the communications system. And I can keep doing this. So I'll go down here. I'll go to the relay link. Copy that. Paste it into here. I'll just keep doing this. Copy that. Where's the next one? S-band relay link. Data router. And I think the last one is the antenna, or the antennas. Okay. All right, so that's 6. 1, 2, 3, 4, 5. Yeah, 6. Now I can simply just drag the communications box down, and now I have instantly made that connection that these subsystems are now a subsystem to the communications system. And I can now keep going down deeper. So now let's say I need to create a relationship between the DTE link and all these other subcomponents here. So I can start with the DTE link as a higher level subsystem, and now I'm going to copy all these components into my assembly structure, and I'll just do the same thing. Okay, and now we have all of the elements, all the components that make up this subassembly are now defined as subsystems to this. So now we've made a start on creating that hierarchical structure in here. So I'm going to keep working on this, and I'll pass it over to Sergio to talk about what he's going to be working on his side, and then we'll get back to actually export this or send this into the SysML model.
Yeah. So Sergio will now start sharing, and he will show the system functions from the same project and how he's going to perform failure modes on it. So once Sergio is done, before these two users commit their changes to server, I'm going to show you in Magic Draw how these two users have logged the different part of the model and adding their changes to it.
Okay, thank you very much, Barney and Paul. You guys can see my Excel, right?
Yeah.
Okay, so at the same time, Paul was starting to change all of the components and subcomponents. I was logging the same project at the same time, so we both were working, let's say, in parallel. You can check the connection on top of the Excel. We have the same revision, the same trunk. The only difference is basically the username or the credentials that we're using for logging in. Now, for this one, I am only going to be expanding a little bit, adding some FMA failure names here. The idea is like to add an error and linking to the continuous capture feed here. This is going to create at the same time in another sync view this relationship here, but in this table we are only going to be able to create it. Here we have to come and give the details for making sure that the model has all the information that it requires. From a numbers side, the SOD numbers here are going to be 8, 4, and 3. These two elements are going to be calculated based on these numbers on a formula that we previously put in one of those in one of these small cells just for dragging down. So just by doing that, we are going to be able to see the numbers being calculated. And as soon as these numbers were calculated, they were already updated with the model. So this is already done in that way. Another way for making this view easier to digest is filtering some of the elements, kind of like the description here. So for the description for this physical failure in the recording device, I'm going to say that the maintenance after every flight cycle has to clean the debris. For the cause, I'm going to be adding also some text in order to describe the cause as the debris operating in the environment affects the recording. And last, the detection is going to be the pilot maneuver. So while doing this, all of this information is going to be in my local environment, right? The only way for this to be part of the model is going to be committing. So I'm not going to commit just yet because I'm going to add a couple of informations now here regarding the sorry, I forgot the name of these ones. This is the requirement matrix. So in this case, I'm going to add a new one for the recording device. And I'm going to link this one with the FMEA that I just created that is already being added here in the column, as you see. And in this case, I only need to add an X. We are not going to be adding anything else. And with that, my part of the of working at the same time on the same trunk project is done. Basically, the only thing that I will need going forward is to commit, but I don't know, Baran, if you want to add more information regarding the other tabs.
Yeah, Paul, sorry. Yeah, Sergio, thank you. Let me share my screen just to show that on Magic Draw, how you two users have obtained the logs. So here, this is the project that Paul and Sergio are working on. As you can see, once they start editing the model, so the users are going to simultaneously edit logs for the elements or the packages that they are going to make changes to. So here you can see the package for Lunar Relay Satellite, LRS, and since the list is empty, you can see there are no components because Paul has not committed his changes to this package yet. But you can see that this package is being logged by Paul, and he's actually working on it. And same way, here you can see for the system behavior package where FMEA, Sergio has obtained logs for this package, and he is continuing to working onto it. And now I'm going to ask Sergio to commit his changes first, and I'll update my model here so we can see that logs will be automatically removed here, and we will see the new elements that Sergio added into this package. Yes, Sergio, once you are done with the commit, please let me know.
Okay, so I added a comment to the commit, and I'm going to commit now. Okay, it has been committed.
So once Sergio has committed, we are seeing the notification that the model has been updated on the server. So I'm going to go into collaborate and update my project to get the latest changes. So once the update is done, we will see the logs being automatically removed, and you can see the logs has been removed here. But since Paul is still working on his part of the model, we still see Paul's log here. And we can also see the new requirement that Sergio created as recording device. So let me bring these here. So here, since I need to make some changes, I need to manually log all these elements so I could bring in these and view it in the diagram. So here you're seeing that Sergio created a new FMEA requirement, and it's called FMEA 03. And he added a failure mode for physical failure in the recording device. So we are able to see this. And then he linked this with the capture continuous feed activity. So here we are seeing the complete link with the connections. So these are all dependencies. So on the Excel front end, Sergio did not worry about creating the stereotypes or creating these dependency. He just continued his workflow in Excel. But all those information or all those edits he made will be transformed as SML elements. So he created a requirement. So that's derived from the failure mode he identified. And this failure mode is an identified from the capture continuous feed. So now I'm going to ask Paul to commit his changes. I'll stop sharing so you can see the way he commits. And but for this section, I'm going to ask Paul to commit it to a new branch. So since Paul worked on the communications part, we are going to create a new branch that's dedicated to the communication subsystem. And once we are comfortable with the communication subsystem, it will be in future linked to the main branch.
Okay. Okay, so while Sergio has been working on his part, I've been busily putting the stick together, the various relationships, hierarchical relationships between the components, the sub-assemblies, and all part of the communications system. And then, of course, all the properties that we want to enter into the systems model. In order to do that, I just simply double-click on the commit icon, and I'll put in a comment in here, communications MEL. I'm going to create a new branch, and I'll call this communications MEL, and just PGE comms system.
Paul, just one. We already have a branch called communication MEL. Can you use communication MEL 1? Yeah, okay.
All right. Okay. Click OK. And that's it. So now I have created my first systems model as a design engineer without knowing anything about SysML. The only work I needed to do was to apply my knowledge to this flat list in order to define those hierarchies. No knowledge of SysML. No, it's just simply added in. So you should be able to see that now, Parani.
Yeah, Paul, can you stop sharing, please? Thank you. So here, for me to see his changes, I'm going to go into collaborate, open the new branch that Paul just added. So here I can see Paul added communication MEL 1. So I'm going to go into this branch and see the latest changes of the component that were imported by Paul. And also, so you saw when Paul was editing, he did not worry about what stereotype has to be added to the components or what kind of units that has to be applied to the values Paul edited in the file, and what kind of relation that he needed to add between the component and the subcomponents. Like, so with SysML, we know that we could add associations. It could be directed composition or aggregation. So all these could be either directed or non-navigable. But so Paul actually did not worry about any of the relation. He just followed the workflow from the Excel worksheet. So here you can see the list that Paul just imported from the Excel. And to see all these relations, I'm going to just log these elements and drag and drop the relation to see the hierarchy. So here, so we have the communication subsystem, and we have the components and their subcomponents. So here you can see that each of these blocks, they have an additional stereotype as components, and you can see their value properties are created with a default units and also a default value for each of the value properties that has been added to the model. So you can see that just by importing the Excel, creating a hierarchy without worrying about any of the SysML semantics, Paul was able to generate a MEL list of components. So now in the next part, Sergio is going to launch another MapleMBSE file. He's going to access these recent components and perform failure modes on it. So he is going to access the same branch that Paul just added. So Paul added the communication MEL1, and we can also see the revision number as 736. So I'll stop sharing. So now Sergio can start this process.
Okay, so let me just share my screen again. So you can see my Excel again?
Yep.
Okay, perfect. So the first thing that I'm going to do, the fastest way to change a MSE file is using restart. So I'm going to restart my MapleMBSE. In this case, because I haven't done any changes that haven't been saved, so I will not lose any information. So I'm just going to say yes. I'm going to use the second MSE file that we prepared for this demo. This one is related to components. And once I select it, I just say okay. In this one, I have to, like we have seen before, once I have put my credentials, I'm going to be able to select a different branch. In this case, we're going to select the MEL1, the one that just was created by Paul. And I'm going to log in by pressing OK. So let's give it a second while it loads. So here in the component table, we are going to see all the components that Paul added already. You can verify the version, the revision, the branch, and all the information on top again regarding the connection that we're using right now to the TWC server. So we're pretty sure this is what Paul just created into a new branch. Here, this is where I'm going to be adding new data. In this case, let's imagine that it is a FC01, and that's going to be a transponder failure. This transponder failure is going to be linked to the KA DT band transponder, which is with an X here. We make sure that that relationship exists. And let's do one second one. But in this case, we are going to be doing a transfer switch failure. And the component that is going to be linked to that one is the WG transforming switch. And again, just with an X, that's enough for creating that relationship. That was everything what that was needed just in this matrix for creating those two. And again, I'm going to have another tab where I'm going to put the different details for these two. Let's start with the SODs for both of them. So for the first one, we're going to be having 9, 4, and 8. And for the second one, we have 6, 3, and 4. Obviously, this is just numbers. We need sometimes more than that for making sure that the model is complete. So we are going to be adding descriptions for both of those. So I'm going to be adding the description for the transponder failure and also the description for the switch failure. Same thing for the causes. In this case, I'm just copy and pasted, but obviously the experts will be able to do this at their own pace. I'm just going as fast as possible for the demo's sake. And last, the detention. So it's going to be the detention and the detention for the switch failure. Again, I'm going to put all of these, hide them, but not because we hide them in Excel, that means they are not part of the model. They are already there. And again, I have a formula here that if I drag, is going to be calculating the information for the model elements and is going to be updated already. This is already part of the internal model. So at this point, the only detail that is missing is to commit, but I will let Barani go back to you and explain a little bit more about this process.
Yeah. So as you can see, we initially performed the failure mode for system function. So we could maintain the same view for a safety engineer. The view that we can provide with Excel is going to remain same, but he will be accessing different part of the model. He will be performing the failure modes with different components or different projects. So as a safety engineer, his job is just to perform FMEA analysis. But instead of him understanding how the modeling tool works, or how the SysML language is, understanding different semantics of it, so it's very easy for them to access the relevant information from the model, edit them, create new descriptions for it, and then save it back to the model. So once they do this, so even though on the front end they are just working with Excel and adding few entries, what MapleMBSE does is it's actually hiding the complexity of SysML language from the user. So now I'll ask Sergio to just go ahead and save it, and we'll see these two new failure modes back in Magic Draw. Okay. Sergio, let me share my screen.
Yeah, okay.
Thank you.
No problem.
So again, here I'm back to Magic Draw. So I'm going to update my project so I get the latest changes that Sergio just committed. So here you can see the new elements that Sergio just added. I'm going to drag and drop it again, so we will see the relations. So here you can see that failure mode that Sergio just added to the WG transfer switch. You can see all the details of it. I'm going to just change the way it's appearing here. Yeah. So here you can see that the information that Sergio added, he created the failure mode with an ID, the cause, detection, and failure for each of these components could be added in the same way. And we can also see the other failure mode same way. We have the failure for transponder, and we see the different numbers for it. So the KADT transponder, the component, so now it's linked to the new failure mode we had. So all these dependencies are just added as a traceability to kind of identify or relate these failure mode to the component. So that's all the workflow that we wanted to show today. I'll pass it back to Paul.
Okay, thanks a lot. So I think really just to wrap up, I mean, I hope you can see from this presentation we've shown here, just how this really does ease the process, and certainly eases that friction that is very often found between project stakeholders and the systems engineering group. And fundamentally, this is what we see MapleMBSE being a very powerful tool. Not only does it remove that friction, it really does build confidence in the process, and by allowing a much broader engagement into the systems engineering process through the systems model. There is actually something in it for everybody to participate, and because we're using a sort of a very simplified front end, very specific view of what can be a very complex model that is specific to a certain task, and you're using Excel, you can get up to speed very, very quickly, and it just makes the whole process a lot quicker and easier. And of course, fundamentally, that reduces errors and costs, and certainly reduces any kinds of risks to the project. And certainly the back end, which we, it's out of the scope for this particular this presentation. The back end of MapleMBSE is extremely open. We have so open APIs and for being able to integrate with other sources of data. And certainly you'll find some examples where we've worked with JPL and Intercax on some of that work. Okay, well, look, let's wrap this up. I just wanted to sort of talk about what we have been doing over the last few months during the lockdown period. If anybody is interested in making a start on this, we are actually providing a free MapleMBSE evaluation license. As you can probably see from the work that we've done here, this is not something you can just simply download and install and away you go. There is a certain amount of setup required in that, and there's a bit of knowledge that we need to sort of handhold you in doing this. So this is typically the reason why we would charge for an evaluation. But certainly for the foreseeable future, we'll be providing a 2-month license with free online training and application support from our team to help make sure that your evaluation is successful. If you'd like to find out more, you can contact us directly at info@MapleMBSE.com.